So, bago natin simulan yung chapter 1, gusto ko lang i-discuss ulit sa inyo yung class policies natin kasi I assume maraming hindi naka-attend last time. So, this is also uploaded sa MVL. Nakikita ba yung screen natin?
Yes, ma'am.
Okay, so let's start. So our core subject for this semester is Mechanics 104 or Mechanics of Deformable Bodies. So sa mga 2018 curriculum, this is your Mechanics 107. So parehas lang naman yung content. Nag-iba lang yung course code dahil nag-iba nga yung curriculum natin dahil sa K-12. So sa mga hindi pa nakakilala sa akin, I'm Engineer Melissa Puntilan. And I am serving Mariano Marcos State University exactly 1 year today. Kasi last year, part-time lang ata ako sa CE 100. Yes, sa CE 100 nyo, part-time lang kasi ako nun. So, nag-full-time ako 1 year, January 28, 2021. So, I am also a graduate of Mariano Marcos State University. So, yung mga instructor na sila Sir Marlon, sila Engineer Karen, Engineer Peñaflor, and Engineer Edra, sila yung mga instructor ko din when I was still studying. So, I am pursuing my master's degree in Mapua University in Manila. So, this is a 4-unit course, and so this is a 4-unit course, meaning we will having 4 hours per week. So, ang schedule natin is Thursday 1 to 5 and Friday 1 to 5. So, kung hindi kayo available sa Friday, pwede kayong umattend ng Thursday and vice versa. So, itong Mechanics of Deformable Bodies is all about the principles of axial stresses and strain, stresses for torsion and bending, combined stresses, beam deflections, indeterminate beams, and elastic instability. So, ito yung pinaka-foundation nyo for your design subject. Ayan. So, kailangan yung i-master tong strength of materials or yung Mechanics 104 para mas mapadali yung pag-intindi nyo on your design subjects. So, by the way, I'm also teaching design subject for the higher years, 3rd year and 4th year. So, yung matututunan nyo dito, ma-apply nyo din when I will be handling your design subjects sa mga susunod na taon or semester. So, our course or ating subject is composed of 6 chapters. Ayan, 6 chapters siya. So, the course requirement, passing grade is 50%, midterm exam 15%, final examination 15%, long exam 50%, quizzes 10%, recitations, assignments, and seatwork is 10%. So, ulitin ko lang, yung midterm exam and final examinations, compulsory po na dapat nating i-take itong dalawang to. So, kung hindi nyo na-take, either midterm or final exam, automatic incomplete na po kayo. So, kung merong mga emergency or for example, na hospital ka, so pwede kang magkaroon ng special exam as long as you inform the instructor ahead of time and then present excuse letter or yung medical certificate. Itong long exams, okay lang na may ma-miss kayo as long as kaya nyo siyang i-cover up on the next chapter. So, dito sa long exam, Averaging lang naman tayo dito. And then, quizzes, 10%. So, itong quizzes, madali lang naman itong mga to. Titignan ko lang kung hanggang saan yung naintindihan nyo sa klase. And then, yung recitations, assignments, and seatwork, 10%. Wala po tayong attendance. Pero once na nagbigay ako ng seatwork, dun po makikita kung sino yung mga nag-a-attend ng aking klase. So, kung di ka nag-attend, wala ka ding seatwork. So, ganun lang naman yun. So, kung di ka nakapag-attend, meaning, walang special special exam for the seatwork, recitations, or assignments. Dapat ito is tinitake on the spot or during our classes or after our class. Tapos magbibigay na lang ako ng certain deadline to finish those activities. And then, ito yung transmutation table natin sa mga nagbabalak or yes, nagbabalak na mauno to. So, you must have an average of 97 to 100%, 125, 92 to 96, and so on. So, yung passing grade natin is 50%. So, it is equivalent to 3.0. And then, below 50% or 40% to 49% is 4.0 or conditional. So, sila po yung magre-removals. And then, below, this must be 40%. So, below 40%, automatically 5.0. So, bagsak na po. Below 40% yung ating average. Okay, so I have some class policies here. So, register to MVLE. Learning materials and assessment activities will be uploaded to this platform. So, take and pass all short, long quizzes, midterm and final examinations, and subject requirements and projects. Solutions to exams, exercises, and plates must be all handwritten and will be submitted in PDF format. So, last time merong nagtanong sa akin kung nagbibigay ba daw ako ng partial points during long exams. Sa MVLE po kasi yung style ko is sinasubdivide ko yung mga sagot. Hindi lang yung final answer yung pinapa-input ko. So, yung mga minor, may mga, for example, nga yung stress, kailangan ng force and area. Pero, pinapa-input ko yung force and then area para magkaroon kayo ng partial points kahit papano, kahit hindi nyo nakuha yung final answer. And then, kalakip ng pagpasa nyo ng exam sa MVLE is yung pagpasa nyo din ng solution. So, kung hindi pinasa yung solutions, i-invalidate po yung sagot nyo sa MVLE. Okay? So, dapat sabay palagi yan. Pag nag-submit ka ng exam mo sa MVLE, automatic mag-submit ka rin ng yung solutions. Okay? I repeat, may invalidate po yung sagot nyo or your final answer sa MVLE kung hindi ka nagpasa ng solutions. Para kung, for example, merong clarification, meron akong i-check na solution. Meron akong titignan na solution. Next, observe honesty and independence during examinations and exercises. Any student caught to be dishonest will be dealt with accordingly based on the college policies. So, ito, hirap nga naman talaga kayong i-monitor during exam. So, nasa sa inyo na yan kung talagang nag-cheat kayo. But I suggest you must work independently. Kasi nga, hindi nyo makikerry itong ugali. Yung pag-cheat, hindi nyo madadala yan sa board exam. Kasi sa board exam talagang napakahigpit. Mahuli ka lang na nag-cheat, ban ka na i-take yung board exam. So, as early as now, practice doing independently. Okay? So, basic naman na yan. And then, next, act and speak decently and appropriately to his or her classmates and instructor. So, make up for missed exams voluntarily. However, only those who have reasonable cause will be granted special examination. So, ito hindi ako yung instructor na nagre-remind sa inyo So, whenever meron kayong na-miss na exam, it's up to you to message me or approach me. Ma'am, hindi po ako nakapag-exam ng ganito. Kailan po yung special exam ko? So, ayun, nagbibigay ako ng special examination as long as meron kayong 28% na medical certificate and you have informed me ahead of time or before the scheduled exam na hindi kayo makakapag-take. Hindi lang yung mag-chat kayo after the exam na hindi kayo nakapag-take. So, it is your responsibility na i-inform yung teacher nyo ahead of time whenever hindi kayo makakapag-take ng exams, midterms, and finals lang yung binibigyan ko. And of course, quizzes, yung binibigyan ko ng special exam. Yung mga sit-works, assignments, and recitations, wala pong special exam. And then, communicate to the instructor concerned for any difficulty encountered in the subject or necessary assistance. So, kung meron kayong hindi naintindihan, open po yung ating GC para magtanong. Okay, hindi po nakakabawas ng pagkatao yung pagtatanong. So, kung meron kayong hindi naintindihan sa klase, i-chat nyo lang dun sa GC natin and sasagutin ko yan sa aking makakaya. Hindi yung pag meron kayong hindi nagustuhan sa klase, i-post nyo na and then magrarat na kayo. Although it's your social media account, wala naman akong pakialam dun kung anong pinupost nyo. Pero what's the point, right? Parang hindi naman nasasagot yung problema nyo by posting. So why not i-direct nyo mismo dun sa teacher kung meron kayong hindi naintindihan sa klase. Okay? So, these are my textbook or references. So, ito yung pinaka-common na ginagamit ko. This one, the Pytel, Andre, and Ferdinand Singer. Ito yung kulay green na pinost ng kaklase nyo kahapon dun sa GC. So, yun yung pinaka-common na ginagamit ko for my references. Available ata siya sa internet if I'm not mistaken. And then, ito yung iba. Ibler, MacGill, yan yung mga ibang references ko. So, do you have any questions for our class policies or grading system? May tanong po ba? And additional lang pala ha, it's not only applicable sa aking subject. Pag hindi ko alam kung kayo yung klase ko last SEM, yung CE100, paulit-ulit kong sinasabi, or last year, paulit-ulit kong sinasabi na pag nagtatanong yung teacher, sumagot kahit yes or no lang. Okay, kasi mahirap nga naman itong virtual class. Computer lang yung kausap ko dito. Okay, so naintindihan po ba?
Yes, ma'am.
Yes, ma'am.
Okay. Ayan. So, para makita ko rin kung baka na-disconnect ako or hindi malinaw yung aking audio. So, ayan. Salamat. So, sumagot lang kung may, or mag-interrupt lang kung meron kayong hindi naintindihan. So, let's start now our discussion. Ayan. So, na-upload ko na rin to sa ating MVL. Okay. So, chapter 1 is all about simple stress. Okay. Pero bago yan, gusto ko munang i-introduce sa inyo yung strength of materials. So, sa engineering mechanics natin, meron tayong 3 fundamental areas. Ito yung statics, dynamics, and strength of materials. So, yung statics nyo is nakuha nyo na last SEM. And then, yung dynamics nyo, magkasabay sila nitong mechanics of deformable bodies. So, dun sa statics nyo, pinag-aralan nyo dun yung mga external forces or external effects ng mga forces sa rigid bodies. So, sa statics, yung mga bagay na hindi gumagalaw. Okay? Sa dynamics naman, pag-aaralan nyo yung mga external effects of forces ng mga bagay na gumagalaw. And then yung ating strema or strength of materials kung tawagin. So yung mechanics of deformable bodies natin is also known as the strength of materials or strema. So dito kino-consider na natin yung mga and internal effects on bodies whenever we apply loads to the body. So deformations are of our major interest here. So even though yung deformation is napakaliit, this is still our major of concern. Kasi as a civil engineer in the future, hindi ka naman magde-design ng structural element that will have excessive deformation. Kasi pag nagkaroon na ng excessive deformation ng structural element, for sure, hindi maganda yung pagkakadesign or may mali sa design. So as a civil engineer, you must take into consideration those minimal deformations. Kasi automatic na yan. Pag nag-design ka ng structural element, meron na yung deformation. Pero very minimal lang. So yun yung mga pinag-aaralan natin dito sa strength of materials. So we have two fundamental concepts here, the strength and the rigidity. So yung strength po na tinatawag is the ability of a material to somehow withstand an applied load without failure, or this is the material's resistance to breakage. Ito yung tinatawag na strength. This is the ability of a material to withstand an applied load without failure, or yung tinatawag nating material's resistance to breakage. And then yung ating rigidity, this is yung resistance or yung material's resistance to bending. So yung strength, material's resistance to breakage. Yung rigidity, material's resistance to bending. Ito yung ma-encounter natin dito sa ating mechanics of deformable bodies. So para mas maintindihan natin yung concept ng strema, we have here arbitrary shape. So kung sa statics nyo, ang ginagawa nyo lang dito is to determine the resultant. Itong mga yung value ng F1, F2, F3, F4. So kinukuha nyo yung resultant nitong arbitrary shape na to, or yung resultant forces ng arbitrary shape na to. Makikita nyo dito pag nag-summation to 0, di ba? Kino-consider nyo static equilibrium. Yung material is in equilibrium pag nag-summation of forces is equal to 0. Dito naman sa strength of materials, i-investigate natin yung mga internal forces na meron dito sa loob ng arbitrary shape natin. So makikita lang natin yung mga internal effects or internal loads if we pass an exploratory section AA. Okay? Yan. Maglalagay tayo ng exploratory section AA dito sa ating arbitrary shape. So, ito na yung kakalabasan natin. So, ito yung ma-expose lahat ng mga internal forces that is acting on the body. So, yung mga forces na to, naka-act lahat sa centroid. So, yung reference is always at the centroid of the body. I think or I assume na pag-aralan nyo na rin yung pagkuha ng centroid ng mga different shapes. Okay? So, yung mga couples or tinatawag nating moments and then the forces are acting on the centroid mismo, or yung reference nila is on the centroid. So, we have here forces and couples that is acting perpendicularly and tangentially to our body. So, yung sinasabi kong forces that is acting perpendicularly, ito yung cross-section natin, di ba? This one. So, papansin nyo, meron tayong force that is acting normal or perpendicular sa ating cross-section. And then, meron naman tayong forces, which is this one, and this one, that is acting tangentially or parallel to our cross-sectional area. So, merong mga special names for those forces. Yan. So, yung mga special names ng ating mga forces is indicated on the second page. So, yung ating PXX or binabasa natin yan as the force on the X phase acting on the X direction. So, ito yon yung ating PXX or the force acting on the X phase. Yan, ito yan. PXX. Yan yung tinatawag nating axial force. So, these components measure the pulling or pushing action perpendicularly to the section. So, a pull represents a tensile force that tends to elongate the member, and a push is a compressive force that tends to shorten it. It is often denoted by P. So, kung yung force daw natin is acting away sa ating cross-sectional area, yun yung tinatawag nating tension. So, yung force is acting away to the cross-sectional area, yung tinatawag nating tension, that tends to elongate or pinapahaba niya yung ating member. Pero kung yung force is acting towards sa ating cross-sectional area, ayan, yung force natin is acting towards our cross-sectional area, yan yung tinatawag nating compression, which tends to compress or pinapaliit niya yung ating subject or yung ating object. Compression. So again, if the pulling force, that's tension. And then yung pushing force is the compression. And then we have the PXY and PXZ, or the force on the X phase acting on the Y direction and Z direction respectively. So, ito yon. Ito naman yung tinatawag nating shear forces. So, ito yon, shear forces. So, the shear forces, ito yung mga force that is acting parallel, okay, parallel sa ating cross-sectional area. And these are components of the total resistance to sliding portion to one side of the exploratory section past the other. The resultant shear force is usually designated by V. And then our torque, or yung ating moment at X phase acting on the X direction, is the component that measures the resistance to twisting the member, designated by T. So ito yung MXX natin, moment at X phase along X direction, and then yung ating moment at the X phase acting on the Y direction, and this must be Z. These are components that measures the resistance to bending the member about the Y or Z axis, and are often denoted by MY or MZ. So, yan yung mga bending moments. So, para mas maintindihan natin, let's consider this one. So, let's consider this box. Itong box na ito, nakikita ba? Mukhang malabo. So, itong box na to, let's consider this as our beam. So, itong box na to, consider nating beam. So, yung cross-sectional area natin is this one. So, if I will apply a force, so for example, this is a force. If I will apply a force, ito yung tinatawag nating axial force. yung force natin is acting perpendicularly to our cross-section. So, nag-act yung ating force dito sa ating cross-section. Yung tinatawag nating axial force that will tend to compress. So, pag nag-compress ito, pag nag-push or nagkaroon ng pushing force, magkakaroon ngayon ng deformation. Liliit itong box natin. And then, if I have a pulling force or yung tension na tinatawag, mag-elongate tong ating box. Kaso, hindi kasi. Example lang, okay? And then, for our shear forces are the forces that is acting parallel sa ating cross-sectional area. Ito yung ating cross-sectional area. I would like to put the force at this part. For example, dito. Magkakaroon tayo dito ng force. So, itutulak niya to. Yan. Itutulak niya yan. So, itong ating box will be divided into two. So, mag-i-slide. So, kung for example, inilagay ko dito, okay? Mahahati ngayon itong ating box. So, hindi ko alam, baka itong part na to is mag-slide paharap. So, nagkakaroon ngayon ng sliding. Dito sa part na to kung saan ko in-apply yung ating force. So, yung area na i-consider natin is the area parallel to our cross-sectional area. And then, so, in-apply ko siya sa Z direction. So, ito yung X direction, Y direction, and then Z direction. So, yung Z direction, imagine niyo is pointing towards you. Okay? So, in-apply ko yung force at the Z direction. So, nagkaroon ngayon ng shear at Z direction. So, mag-i-slide siya dito sa part na to. And if I will apply it on Y direction, so for example, dito ko inilagay yung force. So, baka ang possibility is aangat tong part na to, aangat itong part na to. So, nagkakaroon ngayon ng sliding naman dito sa part na to. Okay, so yung tinatawag natin na shear force. And then sa ating torque, so yung torque natin is the moment acting on the X direction. So yung torque natin is acting on the X direction. So ito yung X natin, di ba? X, Y, Z. So pag naglagay ako ng moment dito sa X direction, mangyayari dito sa box, magkakaroon ngayon ng twisting. Matitwist yan. So maglalagay ako dito ng force, di ba? So matitwist ngayon itong ating box. So yan yung tinatawag na twisting force or yung ating torque. And then, if I will apply a moment at the Y direction. So, dito naman, maglalagay ako ng moment dito. So, anong possibility dito? Ang possibility na mangyari is, magkakaroon ngayon ng bending. Hindi kasi mabend to eh. So, yung ayan. So, dito ko i-rotate, di ba? Kung dito ko i-rotate, ang mangyayari dito, magkakaroon ngayon ng bending at this part. Okay. Magkakaroon ngayon ng bending at this part. And if I will twist or if I will put a moment at the Z direction, so dito sa Z direction, maglalagay ako ng twisting moment dito or bending moment. Ang mangyayari dito is mabebend siya at this part. Okay? So again, sa ating torque, pag naglagay ako ng moment dito sa X direction, ganito yung mangyayari sa ating beam. And pag naglagay ako ng moment sa ating Y direction, dito sa part na to, magkakaroon ng bending. Bending dito, hindi lang kasi masyadong mabend to. Kakaroon ng bending like this one. Ayan. And then pag naglagay naman ako sa Z direction, pointing towards you. Ganyan. So naglalagay ako ng moment. So, ganitong mangyayari sa ating beam. So, naintindihan po ba yung concept ng ating forces and moment?
Yes, ma'am.
Okay? So, yan yung pinaka-basic na kailangan nating tandaan dito sa strength of materials. Yung axial force, shear force, torque, and the bending moment. Okay? Okay, so dito na tayo sa simple stress. So, isang objective ng isang civil engineer is to select the proper material sa isang structure to perform efficiently. So, for example, meron tayo ditong 2 bars that is attached sa ating ceiling. For example, we have here bar 1 and bar 2. So, yung bar 1 and bar 2 natin, they have the same length. Okay? They have the same length. And then yung bar 1 natin, it carries 500 Newton. And yung bar 2 natin, it carries 5,000 Newton. So, at this instance, masasabi ba natin kung saan yung mas malakas ditong bar? So, anyone? Masasabi ba natin dito kung saang bar ang mas malakas or mas mahina? Anyone? So, may I call on Mr. Abero? Mr. Abero? Nandyan ka ba? Gising ka ba? Wala si Mr. Abero. So, may I call on Mr. Mark Robin? Mark Robin? Nandyan ka ba? Wala naman walang attendance dito ngayon.
No, ma'am.
So, hindi natin masasabi at this instant. So, tama. Hindi natin masasabi at this instant kung saan yung mas malakas na bar unless meron tayong basis of comparison na tinatawag. So, malalaman lang natin kung anong bar ang mas malakas if we have yung basis of comparison, which is yung ating area. Okay? So, for example, itong area ng bar 1 natin is 10 square millimeter. And then, yung area ng bar 2 natin is 1,000 square millimeter. So, malalaman mo na ngayon kung saan yung mas malakas by solving for the stress. Okay? Yung stress 1 natin is P all over A. So, yung P natin is the 500 Newton and then the area is 10 square millimeter. So, this is 50 Newton per square millimeter. And then, yung ating stress 2 is P all over A then. So, we have 5,000 Newton all over 1,000 square millimeter. So, it is equal to 5 Newton per square millimeter. So, ang ibig sabihin lang pala nito, dito sa bar 1 natin, in every square millimeter, kaya niyang magbuhat ng 50 Newton. And then dito sa bar 2 natin, in every square millimeter, ang kaya lang niyang buhatin is 5 Newton. So, saan ngayon dito yung mas malakas? Is it bar 1 or bar 2? Saan ang mas malakas? Sa ano? Bar?
Bar 2, ma'am.
Bar 1.
Yan.
Bar 1, ma'am.
Ay, 1, ma'am.
Ayan. So, ang mas malakas dito is bar 1 because kaya niyang buhatin is 50 Newton per square millimeter. So, in every square millimeter, for example, ito yung cross-sectional area. So, kung mag-drawing ka dyan ng maliliit na tagwa 1 millimeter, ayan. So, isang square millimeter, kaya niyang magbuhat ng 50 Newton. So, mas malakas yung ating bar 1. So, yun yung concept ng ating simple stress. Yung simple stress natin is the force all over the area. Yung force in every area. Okay, so yung ating simple stress is denoted as our sigma. Okay, sigma. Or tinatawag nating stress or force unit area. So, kung sa SI, ang ating unit dito is Newton per square meter or Pascal. And then sa English, pounds per square inches or PSI. And then yung ating applied load is denoted as our P. The SI, Newton. English is pounds. And then cross-sectional area, sa SI, square meter. And sa English, square inches. And then we have here the scientific notations with their equivalent prefixes. So, kailangan nating i-familiarize yung sarili natin on these prefixes and scientific notations kasi nakadepende sa problem or kung ano yung binibigay. For example, nagbigay ako ng 1,000 megapascal. So, ano nga ba yung 1,000 megapascal? Yan, nagbigay ako ng 1,000 megapascal. So, kung gusto kong i-convert yan into Pascal, so, ita-times mo lang ng 6 para maging Pascal. Kasi hindi consistent. For example, nagbibigay din ako ng gigapascal, kilopascal. So, anong trip ko bigay? Pero, pinaka-common lang kasi yung megapascal. Pero, kailangan yung familiarize itong mga scientific notations na to. Okay? So, Pascal is Newton per square meter. And yung megapascal natin, since ito yung pinaka-common naman na ginagamit natin, it is equal to Newton per square millimeter. Okay? Megapascal is Newton per square millimeter and Pascal is Newton per square meter. Okay? So, meron bang questions sa ating concept dito sa part 1 bago tayo mag-proceed dito sa mga examples? May questions ba sa concept part?
So far, awan mo.
Ayan. So, mukhang wala naman. So, let's proceed now to our first example. So, a composite bar is consists of an aluminum section rigidly fastened between a bronze section and a steel section as shown. Axial loads are applied at the positions indicated. Determine the stress in each section. So, yung composite bar na tinatawag natin are bar that is composed of different materials. So, dito meron tayong bronze, meron tayong aluminum, and meron tayong steel. And then, meron nag-a-act ng mga forces dito sa ating composite bar. So, ang pinapahanap dito is the stress in each section. Stress dito sa bronze, stress dito sa aluminum, and stress dito sa ating steel. So, para magawa yan, we need to pass an exploratory section that we will call as AA, BB, and CC. So, dito muna tayo sa part ng ating bronze. By the way, yung ating orientation dito, so lahat ng upward is positive, lahat ng downward is negative, to the right, positive, and to the left, negative. Also, counterclockwise direction is negative and clockwise direction is positive. So, ito yung magiging orientation natin for the whole subject. Okay. So, dito na tayo sa ating bronze. For exploratory section AA, set aside natin yung section at the left part ng ating AA. So, nasa sa inyo na yan kung saan nyo gustong magsimula. Pwede rin kayong magsimula dito sa part ng, dito sa right part. Okay, gusto ko lang magsimula dito sa ating AA. Pwede rin dun sa CC. So we have here 17,000 Newton. And then, para magkaroon ng equilibrium, I assume meron tayong force dito na tatawagin natin force D. So let's take the summation of forces along x direction is equal to 0 to the right as positive. So we have negative 17,000 plus PB is equal to 0. Therefore, we have the force B is equal to 17,000 Newton. So solving for the stress, so we have the force all over the cross-sectional area. So we have 17,000 Newton all over area. Ano yung area? We have 775 square millimeters. So this is equal to, so i-calculator ko na lang siya. Paki-interrupt na lang kung mali po yung aking sagot. So I have here 21.935 Newton per square millimeter or 21.935 megapascal. So ito yung sagot natin for the bronze section. So dito naman tayo sa aluminum. So same process lang din. Set aside lang natin yung left part ng ating exploratory section BB. So drawing din natin. Yan. So we have here 17,000. Meron tayo ditong 40,000 Newton. So assume merong force dito that we will call as PA or the force in the aluminum. By the way, yung PB pala natin is in tension. Okay? The force is acting away sa ating area. So tension. So we have here, taking the summation of forces along x direction is equal to 0 to the right as positive. So we have negative 17,000 plus 40,000 minus PA is equal to 0. So yung force natin for the aluminum is equal to 23,000 Newton compression. Therefore, the stress is equal to PA all over AA. So we have 23,000. Area natin is 1,200 square millimeter. So this is equal to 19.167 Newton per square millimeter or 19.167 megapascal. And then, para sa ating steel section, so parehas lang din, ganong process din. So we have dito meron tayong 40,000 and dito meron tayong 9,000. So assume dito tayong PS. So taking the summation of forces along x direction is equal to 0 to the right as positive. So we have negative 17,000 plus 40,000 plus 9,000 minus PS is equal to 0. So the force at this steel section is equal to negative 17,000 plus 40. So we have 32,000. We have 32,000 Newton. And compression siya. So stress now is equal to 32,000 all over cross-sectional area 1,000. So it is equal to 32 megapascal. 32 megapascal. So, ito yung ating example number 1. Paki-screenshot na lang. Someone is raising his hand. Sino yun? Yes, Miss Edna. You're raising your hand.
Ma'am, ano nukat gamit na nukat dito? 30,000 Newton dit. I mean, ano nukat gamit na, ma'am?
Saan yung 30,000?
Dito steel, ma'am.
Dito sa part. Wait lang Nasaan na yung aking screen? This one, 30,000. Kung gusto nyong magsimula dito sa CC, pwede mong gamitin itong 30,000. Sige, try nyo mamaya magsimula dito sa CC, magamit nyo yung 30,000. Same lang makukuha yung mga forces.
Thank you, ma'am.
Para mapatunayan nyo, try nyo mamaya. Okay, so meron pang tanong. Mukhang wala na. Pwede na tayo sa example number 2. So for the truss shown, determine the stress in members AC and BD. The cross-sectional area of each member is 900 square millimeter. Dito, same procedure pa rin, pero kailangan lang natin kunin yung mga forces on each member. So anong pinapakuha dito? We have 4 AC and BD. So kunin natin yung mga internal forces on these two members. Bago natin makuha yan, let's determine first the reactions on each support. So, meron tayo ditong roller. So, sa roller, meron tayong AY. And then, if we have hinge, two reactions. We have HY and then HX. Okay. So, taking the summation of moment at H is equal to 0, clockwise positive. So, we have AY 16 minus 30, moment arm is 12 meters, minus 70, moment arm is 4, is equal to 0. So, yung ating AY is equal to 40 kilonewton. Okay? Yung AY natin is 40 kilonewton. So, taking the summation of forces along y direction is equal to 0, upward as positive. So, meron tayong 40 plus HY minus 30 minus 70 is equal to 0. So, HY now is equal to 60 kilonewton. Okay, so wala naman tayong nakikitang ibang forces that is acting on the x direction. Kaya pwede nating sabihin that Hx is equal to 0. Okay. So, ready na tayo ngayon na i-solve or kunin yung force at member AC by having the joint A. So, separate natin yung joint A. So, meron tayo ditong 40 kilonewton. Assume natin yung ating force AC is in tension and then yung ating force AB is in compression. So, this is PAB and PAC. Slope niya is 4, 3. So, this is 5. Okay. So, taking the summation of forces along y direction is equal to 0. Upward positive. So, meron tayong 40 minus PAB 3 all over 5 equal to 0. So, we have PAB is equal to so this is equal to 66.67 kilonewton. So, tama yung assumptions natin that this is in compression. Okay. And then, taking the summation of forces along x direction is equal to 0 to the right as positive. So, meron tayong negative 4 all over 5 of PAB, which is 66.67. Ayan, plus PAC is equal to 0. So, the force at AC is now equal to so this is equal to 53.33 kilonewton. Positive, so tama that we have tension. So, solving for the stress in member AC, ayan, we have force at AC all over. So, we have 53.33 kilonewton. So, we have times 10 raised to 3 newton all over yung ating area na 900 square millimeter. So, we have 900 square millimeter. Therefore, we have we have 59.26 Newton per square millimeter or 59.26 megapascal. Yan. So, paki-screenshot na lang bago tayo mag-proceed sa member BD. Saburahin ko na. So, for member BD, punta tayo sa joint B. So, at joint B, so yung ating force AB is in compression, which is equal to 66.67 kilonewton. And then, meron tayo ditong force BC. And we have force BE. Okay, so, slope, we have 3, 4, 5. Also have here 3, 4, 5. So, yung PBC pala natin, force at BC natin. So, if I will do the joint C, yan. Yung AC pala natin kanina is, ilan yung AC? We have 53.33, tama? 53.33. So, yung ating PCE is also equal to 53.33. Then, meron tayong 30 kilonewton dito. So, automatically, yung ating force BC is equal to 30 kilonewton in tension. Okay? So, taking the summation of forces vertical. So, PBC is equal to 30 kilonewton in tension. So, this is 30 kilonewton. Okay? So, kunin natin, ano pa pinapakuha? BD. So, kunin muna natin yung forces along y direction is equal to 0, upward as positive. So we have 66.67 slope 3 all over 5 minus 30 ito. Tapos PBE minus slope is also 3 all over 5 is equal to 0. So this is equal to yung ating force BE is equal to 16.67 kilonewton. Then taking the summation, this one is in tension. Taking the summation of forces at along x direction is equal to 0, to the right as positive. So meron tayong 66.67 of 4 all over 5. This one plus 16.67 of 4 all over 5 minus force BD is equal to 0. So yung ating force BD so the force BD is equal to 66.67 kilonewton in compression. So the stress at member BD is equal to force BD all over the area. We have 66.67 times 10 raised to 3 Newton all over 900 square millimeter. So 66.67. So meron tayong 74.08 megapascal. So that is the stress for member BD. So kung gusto kong ipakuha sa inyo yung stress ng member DF, stress ng member EF, ayan, and the other members, ganun din yung gawin ninyo. Kunin nyo muna yung mga forces on each member. Okay? So that's for number 2. Screenshot na lang. Okay, so proceed na tayo sa example number 3. So for example number 3, the block of weight W hangs from the pin at A. Excuse. The bars AB and AC are pinned to the support at B and C. The areas are 800 square millimeter for AB and 400 square millimeter for AC. Neglecting the weights of the bars, determine the maximum safe value of W if the stress in AB is limited to 110 megapascal and that in AC is equal to 120 megapascal. So meron daw tayo ditong block with weight W. It is being supported by member AB and member AC. So yung member AB natin has a cross-sectional area of 800 square millimeter. AC natin is 400 square millimeter. So ano daw yung pinaka-safest value ng ating W para hindi magkaroon ng deformation yung ating AB or AC. Okay, so yung ating AB, it has a stress of 110 megapascal and yung ating AC is 120 megapascal. So the first step here is to draw for the free body diagram para ma-determine yung mga forces ng AB and AC. So let's say this is the W. This is force at AC and force at AB. So, ang goal natin dito is to express AB and AC in terms of W. So, taking the summation of forces along y direction is equal to 0, upward as positive. Meron tayong PAB, sine of 40, tama, plus PAC, sine of 60, minus W is equal to 0. So, let's consider this as our equation number 1. And then, take the summation of forces along x direction is equal to 0, to the right as positive. Meron tayong negative PAB, cosine of 40, tama, plus PAC, cosine of 60 is equal to 0. So, this one, meron tayong PAC equal to PAB cosine of 40 all over cosine of 60. So, simplify pa natin. So, we have PAC equal to so, we have 1.532 of PAB. So, let's consider this as our equation number 2. So, equating equation 1 and equation 2, meron tayong PAB, sine of 40. So, substitute natin si PAC with this value, plus 1.532 PAB, sine 60, minus W is equal to 0. So, meron tayong So, meron tayong 1.969 PAB is equal to W. Therefore, our PAB is equal to 0.508 W. And then, substitute natin ulit dito sa PAC. So, we have 1.532 of 0.508 W. So, yung ating force at AC is equal to 0.778 W. So, meron na tayong value ng PAB and PAC in terms of W. So, ang gagawin natin dyan, we have for stress AB equal to PAB all over the area. So, yung PAB natin is 0. Dito na lang. Stress natin is 110 megapascal or 110 newtons per square millimeter equal to 0.508 of W all over the area, which is 800 square millimeter. Therefore, W is equal to it is equal to 173,228.35 Newton or 173.23 kilonewton. And then for our AC, meron tayong PAC all over AAC. So stress is 120 Newton per square millimeter. PAC is 0.778 of W. And then, yung area natin is 400 square millimeter. So, the W is equal to 61696.65 Newton. So, meron na tayo ngayong dalawang value ng ating W, which is equal to 173.23 kilonewton and 61.7 kilonewton. So, ang magiging final answer natin dito is 61.7 kilonewton. Bakit? Kasi once na i-load natin yung 173.23 kilonewton, for sure mag-fail si member AC. Okay? Yung 173.23 kilonewton, kayang-kayang buhatin ni member AB. But what about member AC? Limit lang kasi ni member AC is 61.7 kilonewton. Kaya hindi mo pwedeng i-load yung 173.23 kilonewton kasi mag-fill nga po si member AC. So, the safest value of W or the safest value of weight pwede ilan is 61.7 kilonewton. Kayang-kaya siyang buhatin ni member AC as well as ng ating member AB without any deformation. So, gets po ba? Naintindihan ba?
Yes, ma'am.
Okay. So, proceed na tayo sa example number 4. Okay. Sample 4 na tayo. So, pakisabi na lang pag hindi nyo pa natapos i-screenshot para balikan natin. For example number 4, a hollow steel tube with an inside diameter of 100 mm must carry a tensile load of 400 kilonewton. Determine the outside diameter of the tube if the stress is limited to 120 meganewton per square meter. So, meron daw tayong hollow steel tube. So, kung hollow steel tube, hollow sa loob. So, meron tayong tube. Ayan. The inside diameter is 100 millimeter. And it has a tensile load of 400 kilonewton. So, meron daw 400 kilonewton tensile load. So, we will determine the outside diameter if the stress is limited to 120 meganewton per square meter. So, kailangan daw nating i-determine yung outside diameter nitong ating hollow steel tube. Okay, so, ang gagawin lang natin dyan, direct substitution lang. We have P all over A. So, the stress is 120. So, Newton per square meter is Pascal. So, this is also equal to 120 megapascal or 120 Newton per square millimeter. So, yung ating P is 400 kilonewton or 400 times 10 raised to 3 Newton. So, ano yung magiging resisting area? So, di ba sa ating simple stress or normal stress, the area is the perpendicular area or yung ating resisting area is the area perpendicularly sa ating force. So, ano yung magiging area natin that is perpendicular to our 400 kilonewton? This one. Since hollow yung ating tube, walang laman yung loob, ito lang yung magiging resisting area. So, it is equal to pi all over 4, the outside diameter minus pi all over 4 of 100 squared. Okay? So, gawin natin, simplify natin. So, the outside diameter is equal to square root of, pwede nyo lang i-direct to sa calculator nyo. 120 plus pi all over 4 of 100 squared divided by pi all over 4. Tama ba? Alam nyo bang gamitin yung shift solve sa calculator nyo? Para mas madali. Divided by square root of pi all over 4. So it is equal to 119.35 millimeter. So ito na yung ating outside diameter. So ang sinasabi kong shift solve sa calculator nyo, i-enter nyo lang to, itong value na to, and then shift solve. So alam nyo ba ang gamitin yan? Alam nyo ba? Anyone?
Yes, ma'am.
Ayun. So, maganda pag-aralan nyo na yung mga shortcuts ng calculator nyo. And, yung mga calculator nyo ba is board exam, or allowed ba sa board exam? Kasi hindi ako makakapagturo sa inyo ng mga shortcuts ng calculator kasi iba yung gamit ko. I'm using the old one, yung winipe out na sa board exam, which is ginagamit ko pa nung nag-aaral ako, the Casio FX991ES. So, tinanggal na to sa board exam, itong klase ng calculator na to. So, I'm suggesting that as early as now, palitan nyo na yung calculator nyo kung hindi siya advisable for board exam. Kasi mahirap mga pag magpapalit pa lang kayo sa board exam ng inyong calculator. So, check nyo sa website ng PRC yung mga allowed calculators for board exam ng civil engineering. May mga list sila doon. Okay, so that's it for number 4. Proceed na tayo sa number 5. Yan. So, a homogeneous 800 kilogram bar AB is supported at either end by a cable as shown. Calculate the smallest area of each cable if the stress is not to exceed 90 megapascal in bronze and 120 megapascal in steel. So, meron na tayo ditong homogeneous bar that weighs 800 kilogram. So, yung pag mga ganitong bagay, saan nag-a-act yung ating weight? So, nag-a-act yung ating weight sa mismong centroid ng ating bar. So, assume natin dito yung centroid is equal to 800 kilogram. Mass po yung binigay. So, lagay na lang natin into weight by multiplying it by 9.81 meter per second squared. So, this is equal to 7,848 Newton. Okay. So, drawing natin yung free body diagram. So, we have here the force at PB. Nakahang daw yung ating 800 kilogram bar. That is, or may naka-attach na bronze and steel end to end. So, this is equal to 7,848 Newton. So, ang gagawin natin dyan, alam naman natin that the weight is acting on the centroid or center of the bar. Therefore, we can say or we can conclude that PB is equal to PS and it is equal to the half of the weight of the bar. Tama? Kasi yung PB and PS natin is naka-attach daw end-to-end ng ating bar. Therefore, equal lang yung force na binubuhat ni bronze and then binubuhat ni steel. So we can say that PB and PS is just the half of 7,848 Newton, which is equal to 3,924 Newton. Okay. So, masasolve na natin agad-agad yung stress at B. So, we have PB all over AB. Stress natin dito is 90 megapascal sa bronze. Dito naman sa steel, we have 120 megapascal. So, 90 newtons per square millimeter equal to 3924 Newton all over area B. So, the area ng ating bronze is equal to 43.6 square millimeter. So, ito na yung ating area for the bronze. And then, for the steel, so we have 120 Newton per square millimeter is equal to PS natin is 3924 all over the area. So, the area is now equal to 32.7 square millimeter. So, yan. So, that is for number 5. So, proceed na tayo sa example number 6. Yan. So, a rod is composed of an aluminum section that is rigidly attached between steel and bronze sections. Axial loads are applied at the positions indicated. If P is equal to 3,000 pounds and the cross-sectional area of the rod is 0.5 square inches, determine the stress in each section. So, yung ating bar or composite bar is rigidly attached to a wall. So, fix dito sa part na to. So, ganun din yung gagawin natin just like the first example. Let's determine the forces that is acting on each section. So, by passing exploratory section AA, BB, and CC. So, the P is 3,000 pounds. Okay. So, for exploratory section AA, so 4P daw, and our P is equal to 3,000 pounds. So, it is equal to 4 times 3,000 is equal to 12,000 pounds. Then, let's say we have here force PS. So, taking the summation of forces along x direction is equal to 0, to the right is positive. So, we have PS is equal to 12,000 pounds. So, the stress is equal to 12,000 pounds all over the area, which is 0.5 square inches. So, this is equal to 24,000 pounds per inches squared, or we can say 24,000 PSI or pounds per square inches. So, ito na yung ating stress at steel. Dito naman tayo sa for exploratory section BB. Same procedure. So this is 12,000 pounds. Then meron tayo ditong PA. So taking the summation of forces along x direction is equal to 0 to the right as positive. So yung ating PA is equal to 12,000 pounds. So the stress is equal to 12,000 all over 0.5 square inches. And it is equal to, same din, 24,000 PSI. So ito yung ating stress at A. Okay? Next, for exploratory section C. Meron tayo dito ng 12,000. We have here 3,000 and a force B. So taking the summation of forces along x direction is equal to 0 to the right as positive. So meron tayong negative 12,000 plus 3,000 plus PB. So PB is equal to 9,000 pounds. And stress at B is equal to 9,000 pounds all over 0.5 square inches. So this is equal to 18,000 PSI. So yun yung stress at B. So dito sa case na to, hindi kayo pwedeng magsimula dito sa section CC. Kasi it is a fixed. Okay, fixed siya. Meaning meron ditong moment and meron ditong forces vertical and horizontal. Kaso, those are unknowns kaya hindi kayo pwedeng magsimula dito sa ating CC. Unlike dun sa first one kanina, kaya may nagtanong kanina kung ano yung silbi ng 30,000 ba yun or 3,000 kilonewton. Kasi yun kasi is free. Walang any support na naka-attach. Kaya pwede kang magsimula on that part. So, pwede mong magamit yung 3,000 kilonewton dun sa part na to. But dito sa part na to, hindi ka pwedeng magsimula dito sa ating section CC. Kasi unknown tong mga values na to. Okay? So, do you have questions so far? Meron bang katanungan?
One, ma'am.
Ayan. So, kung walang tanong, I am giving you a seat work that you will accomplish later on after the class or after itong meeting natin. So, kindly solve for this one. Yan. Paki-complete po mamaya itong ating example number 7. So, this example is just the same nung thrust kanina. Nag-iba lang yung orientation. So, ang gagawin nyo lang naman dito is to solve for the reactions first dito sa A and then reactions at D. And then, solve for, ano ba yung nire-require? AG daw. AG, BC, and CE. Yan. Kunin nyo yung mga internal forces dito sa mga member na to. And then, kung tension daw, gamitin yung stress is 20 KSI. And then, pag compression, 14 KSI. So, yung 20 KSI is 20,000 PSI. Or 20,000 or 20 times 10 raised to 3 PSI. Okay, and then yung 14 KSI is 14 times 10 raised to 3 PSI. Or also read as kilopounds per square inches. Okay, so ilagay nyo lang mamaya sa clean sheet of paper and then upload nyo sa MVLE until 5:30. Maaga naman tayo matatapos ngayon. Hindi ko naman i-consume hanggang 5 p.m. tong klase natin. So, you have enough time to solve for example number 7. So, this will serve as your seat work for today. Okay? So, let's have a 5-minute water break bago tayo mag-proceed sa next topic natin, which is the shearing stress. So, balik kayo after 5 minutes. Water break lang tayo. So let's continue our discussion. So, dito na tayo ngayon sa shearing stress. So, as I have discussed kanina, shearing stress is the force that is acting parallel sa ating cross-sectional area, while the normal stress is the force acting perpendicularly sa ating area. So, tensile and compressive stresses are frequently called normal stress, whereas a shearing stress may be called as our tangential stress. Tangential, tangent to the cross-sectional area or parallel to the cross-sectional area yung force na nag-act sa ating body. So, a shearing stress is produced whenever the applied loads cause one section of a body to tend to slide past its adjacent section. So, we have here three illustrations ng shearing stresses. Okay, yung illustration number 1 natin. So, the rivet resists shear across its cross-sectional area and it is considered as our single shear. So, dito, meron tayong two metal plates. This is plate 1 and plate 2. So, they are being joined together by a rivet. So, ito yung ating rivet. Ayan. So, kung naglagay tayo ng force dito at the one side and then dito sa side na to, a force P, the rivet will tend to resist yung sliding nitong dalawang plate na to. Okay, so ang magiging cross-sectional area ng rivet or the resisting cross-sectional area would be this one. So, kunwari, top view tayo. Okay, so ito yung plate 1 natin. And then yung ating plate 2. Ayan, yung plate 2. And then this is the rivet. Yan, yung rivet natin. Top view to So, ang magiging cross-sectional area, resisting cross-sectional area would be this one. Okay, kasi yung force, yan yung force P. So, ano yung force P? That is parallel or yung cross-sectional area that is parallel to the force P. So, ito yan. So, this is the resisting area which is equal to pi d squared all over 4. Okay? So, yan yung concept ng single shear. Isang cross-sectional area lang yung nagre-resist dito sa ating material. Kaya single shear. Then, the illustration number 2, the clevis of the bolt resists shear across two cross-sectional areas or what we call the double shear. For example, meron tayo ditong force P. Ayan. So, ano yung mga resisting area? So, para hindi gumalaw itong ating clevis, the resisting area is yung area ng ating, for example, this is bolt and nut. This one, yung resisting area. Okay? Yan yung resisting area ng ating clevis. Which is, for example, kung itong ating bolts and nut, it has a diameter of D. So, ang magiging resisting area is just twice the area of this one. Okay. Nagre-resist yan. Para hindi gumalaw yung ating clevis, meron tayong ditong force P, dito na part na to, and then another shearing force na i-resist yung ating P para hindi gumalaw. And then we have here for illustration, letter C, we have the circular slug that is about to be punched out of a plate. The resisting area is similar to a milled edge of a coin. For example, meron tayong ditong plate. Ito yung plate natin, metal plate. And if we apply a force P, magkakaroon ngayon ng tinatawag nating punching shear. So, top view, example top view yan. Kung gusto kong mag-punch out dito ng a certain D diameter, anong magiging resisting area? Resisting area ng ating P. So, magiging resisting area is the circumference multiplied by the thickness. Kung i-3D natin yan, ayan. So, kunwari, ito yung natanggal na metal dito sa part na to. Ang resisting area is this one. Ayan. Which is equal to the circumference multiplied by the thickness of the plate. Okay? And then yung ating plate, for example, yung natanggalan na. Diba? Wala na dito, hollow na dito sa part na to. Hollow na dyan sa part na yan, for example. So, ito yung resisting area. Similar to the edge of a coin. Okay? So, yung piso, for example, just the circumference multiplied by the thickness. Yun yung magiging resisting area. I-resist dyan sa part na yan. Yung ating force P. Okay? Yun yung three basic concept ng ating shear stress. So, yung ating shearing stress is denoted as the tau. Yan, tau. Kung sa normal stress kanina, sigma. Dito naman, tau. Okay? Shearing stress is tau, which is equal to the applied load, or V, divided by the cross-sectional area. V or P, parehas lang yan. Kasi dito kasi sa shearing stress, we are using the shear force as shear force as V. Okay? And then sa normal stress, we are using the force as P. So, pag nakita kayo ng V, it signifies automatically as shear force. Okay? And then yung area natin is the cross-sectional area that is parallel to the force. Para mas maintindihan natin, let's proceed to our example number 1. Ang sabi dito, what force is required to punch a 20 mm diameter hole in a plate that is 25 mm thick? The shear strength is 350 meganewton per square meter. So, this example is just the same, the illustration number 3 or the illustration C kanina. So, meron daw tayong plate that is 25 mm thick. So, this is 25, excuse me, 25 mm in thickness. And then we need to punch a 20 mm diameter hole. So, this is 20 mm diameter hole. So, ano daw yung kailangan nating shear force para ma-punch out yung 20 mm diameter if we have a shear strength of 350 megapascal. Okay, Newton per square meter is again Pascal, kaya naging megapascal. So, direct substitution. We have the shearing stress equal to the shear force all over the resisting area. So, meron tayong 350 Newton per square millimeter is equal to, V is just the same with P. Okay? So, sabihin natin this is V is equal to, ano yung magiging resisting area? The resisting area Gaya ng sabi ko kanina, this one. Yung magiging resisting area, which is equal to the circumference multiplied by the thickness. So we have pi d, circumference multiplied by the thickness. Okay, so meron na tayo ditong diameter, which is 20 mm. And then thickness, which is equal to 25 mm. Therefore, the shear force is equal to 549,778.71 Newton, or 549.78 kilo Newton. So this is the required force we need to punch a hole that is 20 millimeter in diameter. Okay? So proceed na tayo sa example number 2 kung walang tanong. A hole is to be punched out of a plate having a shearing strength of 40 ksi. So the compressive stress in the punch is limited to 50 ksi. For letter A, compute the maximum thickness of plate in which a hole 2.5 inches in diameter can be punched. For letter B, if the plate is 0.25 inches thick, determine the diameter of the smallest hole that can be punched. Okay. So, meron daw tayong shearing strength of 40 KSI or kilopounds per inches squared. And then yung compressive stress daw natin is equal to 50 KSI. So for letter A, compute the maximum thickness in which a hole of 2.5 inches in diameter is to be punched out. And kung gagawin natin dyan, we will use yung normal force muna. So stress is equal to P all over A. Meron tayong 50 times 10 raised to 3 pounds per inches squared is equal to P all over. Kapag normal stress, ano yung gagamitin nating area? The area that is perpendicular to our force P, which is equal to pi d squared all over 4. Right? So, ito yung ating force P, perpendicular. So, ito yung area. Kaya naging pi d squared all over 4. On which yung ating D is 2.5 inches. So, direct substitution. Therefore, ang ating P is equal to 245,436.93 pounds. Now, proceed tayo sa shear force, which is equal to, or shearing stress, which is equal to V all over A. So, we have 40 times 10 raised to 3 is equal to, sabi nga kanina, P is equal to V. So, meron tayong 245,436.93. And then, the area, the resisting area is, so shearing tayo, resisting area is this one. Okay. So, we have pi dt. on which meron na tayong diameter which is equal to 2.5 inches. So, our T or the thickness is equal to is equal to 0.78 inches. So, this is our answer for letter A. And then for letter B, if the plate is 0.25 inches thick, determine the diameter of the smallest hole that can be punched. Okay. So, ganun din. Gamitin natin si normal stress. So, we have P all over A. So, we have 50 times 10 raised to 3. P, ang magiging area natin is pi d squared all over 4. Pi d squared all over 4. So, ang ating P is equal to equal to 12,500 pi d squared. And then for our shearing stress is equal to V all over A. So we have 40 times 10 raised to 3. Yung ating V is just the same with P. Therefore, 12,500 pi d squared, the resisting area is pi dt. We have pi d, thickness is 0.25. So, cancel out, cancel, cancel, cancel. Therefore, our D or the diameter is now equal to it is equal to 0.8 inches. So, this is for letter D. Okay? So, may katanungan ba? Bago tayo mag-proceed sa iba. One to 5 yung ating klase. Mahirap labanan yung antok ng 1 to 3. Nalagpasan na natin, alas 3 na. So, I think wala namang tanong. Proceed na tayo sa number 3. Find the smallest diameter bolt that can be used in the clevis if P is equal to 400 kilonewton. The shearing strength of the bolt is 300 megapascal. So, meron daw tayo dito clevis. Yung value ng ating P is equal to 400 kilonewton. Pinapadetermine lang naman dito yung smallest diameter of the bolt to resist a shearing stress of 300 megapascal. So, ito yung ating bolt. Ito. This one. Ayan. So, naka-attach sa dito sa clevis natin. Yung ating bolt. So, direct substitution lang. The shearing stress is equal to the shearing force all over the area. The shearing strength is 300 megapascal or 300 Newton per square millimeter. P is just the same with our shearing force. So we have 400 times 10 raised to 3 Newton. And this is a double shear kasi dalawa yung resisting area na nagre-resist sa ating P, which is area at this portion and then area at this part. So we have just twice the area of the ball. Pi d squared all over 4. Ito yung sinasabi natin ngayong double shear. So, ang concept nito, again, there is a two resisting area here. Ayan. Kaya double shear. Pinipigilan ng dalawang area na to yung paggalaw ng ating clevis. Okay. So, our D now is equal to 29.13 millimeters. So, that's the smallest diameter of the bolt. Ang dali lang, di ba? Sana ganyan din sa exam. Okay, so proceed na tayo sa example number 4. A 200 millimeter diameter pulley is prevented from rotating relative to 60 millimeter diameter shaft by a 70 millimeter long key. If a torque of 2.2 kilonewton that meter is applied to the shaft, determine the width B if the allowable shearing stress in the key is 60 megapascal. So, meron tayo ditong shaft or a rotating pulley. Okay. So, to prevent yung pag-ikot ng ating pulley, naglagay sila ng parang lock or tinatawag nilang key, which is this one. Nilalagay nila dyan to prevent the rotation of the pulley. Kapag nag-apply ka ng torque here, okay, prevent ng key yung pag-rotate ng ating pulley. Kasi di ba pag nag-rotate dito, nilagyan mo dito siya ng twisting moment, iikot yung ating pulley. And to be able to prevent that, nilalagyan nila ng tinatawag nilang key. So the problem is asking for the dimension of this key to prevent it from rotating. Okay. So ang gagawin natin dyan is to draw for the free body diagram para mas maintindihan natin yung concept nito. So we have here the shaft. Okay. Nilagyan nila ng key. Ayan yung key. So yung shaft, it has a torque of 2.2 kilonewton that meter. So yung silbi ng key dito is to prevent this shaft from rotating with a force of F. So kailangan ng force F to resist the rotation of our shaft or ng ating pulley. Okay. So this one, the diameter of the shaft is 60 millimeter. We have 60 millimeter. By taking the summation of the moment at the center, so dito yung center natin, taking the summation of the moment at center is equal to 0, clockwise as positive. So we have negative 2.2 kilonewton that meter or 2.2 times 10 raised to 6 newton that millimeter. Okay, so paano naging kilonewton times 10 raised to 6 yan? Kilonewton times 10 raised to 3. And then yung meter to millimeter times 10 raised to 3. Kaya meron tayong times 10 raised to 6. Okay, plus F, yung force natin, moment arm is just the radius, which is equal to 30 millimeter. It's equal to 0. F is equal to so F is equal to 73,333 Newton. So that's the value of our F. Now, let's determine the value of P. So yung F natin, dito yon. Ito yung F. Dito nag-act yung ating force F. So our shearing stress is equal to V all over A. So ilan yung shearing stress natin? Shearing stress is 60 megapascal. We have 60 Newton per square millimeter. So, yung force, nagre-resist this from rotating is 73,333.33 Newton. And ano yung magiging resisting area? Area that is parallel to our F. Tama? So, ano yung area ngayon na yun? So, ito yung ating T. Ayan. So, dito nag-a-act yung ating force F. Tama? Ano yung area that is parallel to force F? This area, which is equal to 70 millimeter multiplied by the width B. Okay, yun yung magiging resisting area. Basta lagi nyo yung tatandaan that the shearing stress, parallel yung area na kailangan. Parallel to the force. So, we have 70 multiplied by the B. Therefore, B is equal to 17.46 millimeter. So, this is our final answer. 17.46. Okay, so proceed na tayo sa next example. So, compute the shearing stress in the pin at B for the member supported as shown. The pin diameter is 20 millimeter. Okay, so meron tayo dito structural element, and this is the elevation, or let's say left elevation, tama, left elevation dito sa support at B. So since ganito yung elevation niya, we can say that this is in double shear. Double shear yung may encounter natin dito. Okay, bago tayo mag-proceed dyan, let's first solve for the forces or the reactions at each support. So, this is a hinge. So, meron tayo dito BY. And this one, meron tayo BX. Okay. And then, dito meron tayong CY. So, taking the summation of moment at P is equal to 0. Clockwise, positive. So, meron tayong negative CY. Moment arm is 250. Okay. Plus, so ito, the vertical component is, excuse me, 40 sine of 35. And then this one, meron tayong 40 cosine of 35. So, plus 40 cosine of 35, the moment arm is 200. Okay, is equal to 0. Therefore, CY is equal to CY is equal to 26.21 kilonewton. Okay, so taking the summation of forces, horizontal is equal to 0, to the right as positive. So meron tayong 40 cosine of 35 minus Bx is equal to 0. So, Bx is equal to 32.77 kilonewton. And then, taking the summation of forces, medyo nalilito ako dito. X, okay? Huwag kayong malito dito. Minsan kasi ginagamit ko is H or V. Horizontal H, V as vertical. So, it is Y is equal to 0. Okay? Upward as positive. So, meron tayong dy plus yung CY natin, which is 26.21 plus 40 sine of 35 is equal to 0. Therefore, dy is equal to 49 or negative 49.15 kilonewton. So, mali yung assumptions natin. Dapat By is 49.15 kilonewton downward. Okay? So, ang kailangan natin is the force at B. Force that is acting at our pin B. By having the resultant of x and y, which is equal to bx squared plus by squared. So this is equal to 32.77 squared plus 49.15 squared. So the force at pin B is equal to 59.07. Therefore, we are now ready to compute for the shearing stress at pin B. So, shearing stress is equal to V all over A. So, yung ating V is equal to 59.07 times 10 raised to 3 Newton. And yung area natin, sabi nga kanina, this is double shear kasi yung ating pin dito, magre-resist siya this part, dalawa. Therefore, twice of pi d squared all over 4, on which yung ating d is equal to 20 mm. Therefore, our shearing stress is equal to 94.04 Newton per square millimeter. So this is the required shearing stress at point. Okay? Screenshot na. So, proceed tayo sa example number 6. So, the member or the members of the structure weigh 200 pounds per foot. Determine the smallest diameter pin that can be used at A if the shearing stress is limited to 5,000 psi. Assume single shear. Okay? So, yung ating member AB and member BC weighs 200 pounds per foot. Kunin muna natin yung length ng AB and length ng ating BC. So, for AB, it's just a square root of 4 squared plus 6 minus 2. So, 4 squared. So, it is equal to 5.66 feet. And then yung ating BC, have 6 squared plus 3 squared. So this is equal to 6.71. So ang gagawin natin dito is to solve for the reactions at B gawin B first bago natin makuha yung reactions ng A and C. Kasi kung mapapansin nyo, this one is hinge. Also with this one, hinge. So this is an indeterminate structure. Okay? Indeterminate structure meaning hindi natin masosolve basta-basta yung mga reactions ng ating supports by the with only using the three equations of equilibrium, which is the summation of forces along x direction, summation of forces along y direction, and then the summation of moment. So kahit anong gawin mo dyan, kahit gamitin mo yung tatlong equations na to, hindi mo masosolve yung values ng A and C kasi indeterminate sila. So ang gagawin natin dito is to dissect these elements parts by parts. Okay? So unahin natin yung ating AB. So for member AB, i-drawing natin yung free body diagram. So we have here AY, AX, then BX, and we have our BY. So yung ating member AB, is 5'6" and it weighs 200 pounds per foot. So 200 pounds per foot, meaning 200 pounds kada length, kada foot. So, multiply lang natin siya with the length. Okay, 5.66. So, this is equal to 1,132 pounds. Okay. So, let's take the summation. Moment at A is equal to 0. Clockwise positive. So we have negative Bx. Okay. This one is 4 feet and this one is 4 feet. Negative Bx. Moment arm is 4. Tama. Minus By. Moment arm is 4 also. Plus 1,132 moment arm is 2. Equal to 0. So, simplify natin siya. So, we have negative 4bx minus 4by plus 2264 is equal to 0. So, simplifying this further, we have negative bx minus by plus 2264 is equal to 0. So, this is our equation number 1. So, same procedure, gawin natin to dun sa ating member BC. Okay. Kung ano yung in-apply mo ditong load, reciprocal lang pag lilipat na tayo sa member BC. Okay. Kung dito to the right, ay to the left, so gawin natin dito to the right. So, we have bx. Kung dito upward, gawin natin downward. So, we have by. And then we have here our cy and cx. And then yung ating weight is 200 multiplied by 6.71. So member BC is 6.71 in length. So we have 200 multiplied by 6.71. So we have 1,342 pounds. Okay. So ganun din. Let's take the summation of moment at C is equal to 0, clockwise as positive. So this is 3 feet and 6. Okay. So meron tayong dx, moment arm is 6. Okay. Minus by, moment arm is 3. Minus 1342 moment arm is 1.5 is equal to 0.
Excuse me, ma'am. Excuse me.
Yes?
Ma'am, maglalagay.
Yes?
Screen, ma'am. May masurutan. DJ, ano, ma'am. Pen mo, ma'am. Naglalag. Screen mo, ma'am.
So saan ako natapos sa inyo? Nasa busy na ako. Wala ba
Nag-start nga,
nagtuturo? Kasi
naglagtatag. Nag-start, naglagtatag. Summation of moments at A, ma'am.
What about the others?
Same, ma'am. Same with summation of moments.
Same,
at
ma'am.
Okay, so wait lang ha. So wala pang summation of moment at C. Wala pa si screen nyo?
1.5, ma'am. Ay, dito lang first equation, ma'am.
Okay lang. Dun sa BX multiplied by 6. Dun na ako sa part na yun. Meron na si screen ninyo.
Nakikita na namin, ma'am. Yes, ma'am.
So, okay na. So, sige, try kong magsulat. So, dito, 6bx minus 3by. So, okay na? Nasusundan na ba? Okay na
Oo,
ba?
nagparang ay,
So, meron akong equation dito.
nagde-delay po, ma'am, mga 5 to 10 seconds po.
Siguro pagod na rin yung pen ko. Wait lang. Kasi na-end ko kasi nag-leave na kit ma-perdi no pagi recordings. So, I'm writing dito sa gilid. Nakikita ba? Delay pa rin ba?
Okay na po, ma'am.
Okay na. So, okay, let's proceed. Nabannog mo sa event. Malapit naman na matapos. Dalawang example na lang. So, we have here the equation number 2. Okay. So, equating 1 and 2. Alam niyo ba yung pag-solve using your calculator ng 2 unknowns? 2 equations and 2 unknowns. Alam niyo po ba yan?
Yes, ma'am.
Ayan. So, pwede niyong i-direct this one sa equations para mas madali. Kasi hindi naman na to yung main focus kasi natin. Kaya hindi ko na siya ito terms of bx or by. So, solve niyo na lang using your calculator. I assume alam niyo na yung mano-mano nito. Manual computation. Hindi ko kasi pwedeng ituro sa inyo kasi iba yung gamit kong calculator. Malilito lang kayo. Marami namang tutorial sa YouTube ng mga calculators nyo kung paano sila nagpo-function. So, Bx is equal to 153.67 and By is 412.34 pounds. So, pa-double check na kung parehas tayo ng nakuha. Mukhang merong mali dito sa ating equation number. This one. Hindi siya na. This must be 2264 divided by 4. Tama? So, it must be 566. This is 566 para makuha yung value ng 153.67 and 412.34. Ayan. So, it is equal to 412 and then 153.67. Baliktad. So, this is By. Baliktad yung input ko. So, this is By and this is Bx. Okay. So, meron tayong value ng B. Therefore, magagamit na natin siya in solving for reactions at A. So, having summation of forces. Gamitin natin itong illustration number 1, okay? Meron tayong Bx na 412.34 and then yung By natin is 153.67. So, ito yung gamitin natin. So, taking the summation of forces vertical is equal to 0, upward positive. So, we have 153.67 plus Ay minus 1132 is equal to 0. Therefore, Ay is equal to it is equal to 978.33 pounds. And then, taking the summation of forces along x direction to the right as positive. So, meron tayong Ax minus 412.34 is equal to 0. Therefore, AX is equal to 412.34 pounds. So, the force at A is just the resultant of AX and AY. So, let's say PA is equal to square root of AX squared plus AY squared, which is equal to is equal to 1,061.68 pounds. So that's the force at A. So ano ba yung hinahanap ng problem? Smallest diameter pin that can be used at A if the shearing stress is limited to 5,000 psi. Assume single shear. So, single shear daw siya. So, kung titignan natin dito sa A, gawin natin yung elevation niya. So, this is support at A. Ayan. So, ito yung structural member AB. Okay? Yan yung structural member. So, ang nagdudugtong sa pin at A, support at A, and then yung structural member AB is a pin. Dito. Yan, may naka-attach na pin dyan. Kaya sabi niya, single shear daw lang yung consider natin. So, yung resisting area is just this one. Dito sa part na to. Okay? Kasi yung sabi nga, single shear. Unlike dun sa previous example natin, sabi niya, double shear. Ano ba yung previous example natin? This one, ayan. Double shear. Yung ating member AB, iniipit siya ng magkabilang support. This one and this one. Kaya nagkaroon ng double shear. Okay, dito, single shear lang daw. Ganito yung itsura. Okay. Yan yung support. Ito yung ating member AB. Ito yung ating P. Kaya single shear lang i-consider natin. Therefore, at A is equal to, hindi pala stress, sorry. Shear. So, the shearing stress is equal to V all over A, and which yung ating shearing stress is limited to 5,000 psi or pounds per inches squared is equal to V 1,061.68 pounds all over resisting area is pi d squared all over 4. Therefore, D is equal to okay. So, yung ating D is equal to 0.52 inches. So, this is our final answer. Ang yung whole solution. And we are down to our last example. Okay, for example, number 7. According to the figure, compute the maximum force P that can be applied by the machine operator if the shearing stress in the pin at B and the actual stress in the control rod at C are limited to 4,000 psi and 5,000 psi respectively. The diameters are 0.25 inch for the pin and 0.5 inch for the control rod. Assume single shear for the pin at So, para mas mapadali yung pag-intindi natin dito sa problem, we will try to draw the free body diagram. It's medyo complex pag tinitignan lang natin itong illustration dito. So, we have a force P coming from the machine operator. We have support at B. That's pin support. Therefore, gagawin natin dyan, we have By and Bx. And then we have this force T that is applied 10 degrees with the horizontal. Okay, so this is 6 inches and this is 2 inches. The shearing stress at pin B, yung shearing stress daw dito at pin B is equal to 4,000 psi. And then, yung control rod at C, so ito yung control rod natin, meron siyang axial stress of 5,000 psi. The diameters at the pin is 0.25 and 0.5 inches for the control rod. Diameter. Diameter at B is 0.25. Diameter at C is 0.5. Okay. Ang gagawin natin dyan, let's take the summation of moment at P is equal to 0. Clockwise positive. So, meron tayong, this one is T. So, yung horizontal component, this one is T cosine of 10 degrees. And then we have here T sine of 10 degrees. Tama. So, we have T sine of 10 degrees. Moment arm is 2 inches minus P multiplied by 6 is equal to 0. So, let's extract or make P in terms of T. So, we have 0.347 T equal to 60. Therefore, P is equal to 0.0579 T. And this will serve as our equation number 1. And then let's take the summation of forces along horizontal is equal to 0. To the right as positive. So, meron tayong T cosine of 10 degrees. Okay, minus Bx is equal to 0. Therefore, Bx is equal to cosine 10, we have 0.984 T. And so, this is our equation number 2. And then, taking the summation of forces vertical is equal to 0, upward positive. So, meron tayong dy minus T sine 10 minus T is equal to 0. So, ating dy minus yung ating T, okay, T sine 10, yung ating T is 0.0579 T equal to 0. Okay. Therefore, our dy, express natin in terms of T. So, meron tayong meron tayong 0.231 T. So, ito yung maging equation number 3 natin. Okay? So, meron tayong shear at P. So, yung shear natin is equal to VB all over the area, on which yung ating shear daw is 4,000 PSI. Yung ating VB, yan yung unknown. And then yung area natin is pi d squared all over 4, on which yung ating D is 0.25. Okay? Single shear lang daw po dito sa ating team D. Kaya single shear lang yung consider ko sa ating area. I mean, single area lang yung consider ko dito. Okay? So, yung ating shear force now at D is equal to equal to 196.35 pounds. Okay? On which, yung ating force B is just the resultant of bx squared plus by squared. Tama? So, substitute natin. We have yung ating bx, which is 0.984 t squared plus yung ating by, 0.231 t squared. And yung ating shear force is 196.35 pounds. So, using your calculator, we can now solve for the value of P. So, our T is equal to 194.26 pounds. Anong pinapahanap ba? Force P. Compute the maximum force P. So, by using equation number 1, we can solve for the value of P. So, P is equal to 0.0579 multiplied by T, on which yung ating T is 194.26 pounds. Therefore, P is equal to 11.24 pounds. So, this would be our final answer. Okay, so screenshot na lang. Yan. So, that's it for our first official meeting in Mechanics 104. So, meron bang mga katanungan, clarifications? Meron bang questions, clarifications? Anyone?
Ma'am, can we have a copy of the PDF na na-annotate mo, ma'am? The solution na, ma'am.
PDF? Wala akong ganun. Kaya pinapakopya ko kayo. Yung ano, yung?
I mean, that yung screenshot mo, ma'am, do you have the copy of the PDF na mabalin na nai-exported, ma'am, with the solutions, ma'am?
Oh, you mean a PDF with solutions?
Yes, ma'am. Already, na-ubra tayo, ma'am.
Wala, hindi ako gumagawa ng ganun. Kaya pinapakopya ko kayo or pinapa-screenshot ko kayo. Para
Okay.
kaya na yung komopya. So ano
Ma'am,
pa?
mabalin lang tangar without solution latan.
Ano?
Data PDF. Data PDF mo ma'am, without solution mabalin isend mo latan ma'am. Uri
Nasa
awan di solution
MVLE.
mo.
Nasa
Nasa
MVLE.
MBLE ma'am.
Yep,
Sige ma'am.
in-upload
Thank you
ko
ma'am.
na sa MVLE. Ina-upload ko yung mga module natin before class para ma-print nyo na para kumopya na lang yung solutions yung gagawin nyo. So, ganun yung style ko. So, I expect na meron na kayong copy ng aking dinidiscuss bago pa ako magsimula. Para hindi na kayo kukopya ng problem. Solutions na lang. So, any more questions? Para magawa nyo na yung sheet work. So, mukhang wala naman na ata. So, kindly turn on your cameras for the documentation. Okay? So, smile lang smile dyan. Okay, 1, 2, 3. So, kung wala nang katanungan, pwede na kayong mag-leave. So, gusto ko lang ipaalala yung sheet work nyo. It will, deadline is 5 p.m. Madali lang naman yun. Few minutes lang, kayang-kanya yun. Ilagay nyo sa clean sheet of bond paper and then save it in PDF format. Upload nyo sa MVL. Okay? So, thank you everyone. See you next week. Stay safe.
Thank you, ma'am.
Okay ma'am.
Sige ma'am.